Today, we will introduce another tool called Pump Sizing and Pressure Drop Calculator. Before we go to details, there are some limits by using this tool. First, this can only be applied to liquid-only medium. Second, this is designed for single pipe, not multiple branches. By the way, we do have this tool on our website. Again, we will have both imperial and metric measurement units in the system. The first step is to select the transferring liquid. Based on the temperature you select, the density and viscosity will be automatically calculated. Of course, you are welcome to change the value to override it if you want to. Then we will go to the system conditions. Enter the design flow rate, pump altitude. The gravity constant and atmosphere pressure will be auto-calculated. You will also need to enter the liquid elevation at suction side. This will change the NPSHa value. The evaporation pressure is determined by the liquid you select, but you can change the value you want. Also enter the pump destination pressure. Step 2 will determine the pipe size and fittings on the suction section. You can choose the pipe material, type and size. The dimension and roughness of the pipe will be auto-calculated based on your selection. Of course, you can manually change that to override. Some of the pipe size are not common, and you also need to manually enter the value. Then enter the horizontal length and vertical length of the pipe. The vertical one can be auto-calculated based on your selection on step 1. After getting the piping done, we will go to the section of fittings to determine minor losses. We have most of the fittings and valves pre-calculated in the database. You can change the KTI, opening conditions, and K value if necessary. You will find results in step 3 for all suction line dynamics and NPSHa. All reference and formula can be found also. Then we will go to step 4 to determine the pump discharge sections. We are basically using the same logics. Select the pipe material type and size to determine pipe dimensions and roughness. Also enter the pipe length including horizontal and vertical ones. Then we will enter fitting and valve TIS including the valve opening conditions. After all K value are calculated, the discharge TDH and pump power can be found in step 5. There is a section to key in the pump efficiency. This will generate the power needed for the pump. Step 6 is the pump inquiry datasheet. Basically, you can use this to send to pump manufacturer for proper selection and quote. Step 7 is used to determine the pump operating point and generate system curve. We can choose the pump tie and arrangement. Usually, we will arrange pumps in parallel or series, which will significantly change the pump performance. Input the pump curve data. If you need more rows, just click the plus sign in the bottom. You can also delete the row you don't need. Then we can see the intersection point between pump curve and system curve. This point will be the operation point based on the pump you select. Please be noted that this does not always equal to your design target. For example, in this case, your target flow rate is 70 GPM, but based on your pump selection, this pump will generate 100 GPM in the system. You need to either change a new pump or accept you will have 100 GPM in the system. Also based on your pump data input, the calculator will auto-calculate and compare the net positive suction head required and net positive suction head available to prevent pump cavitation. Please also be noted that if you have more than one pump, the system will auto-generate a single pump curve, and you should focus the single pump duty point in around the pump best efficient point and within the preferred operating range. This can significantly increase the pump life. Thank you for using the tool, and the product link is provided. You are welcome to visit our website for additional 100+ tools.